या फिर कॉपी मुझे वापस दे दीजिए ना, क्योंकि फिर मैं खुद ही जो है ना वो आपके बिल के साथ उसकी कॉपी करवा के लगा आपका अपॉइंटमेंट ऑर्डर भी मिल पाएगा।
ठीक है सर, आपने हमारे डिपार्टमेंट से लिया है?
आपको अपॉइंटमेंट ऑर्डर को हाँ सॉरी सॉरी सॉरी
सर वो मेरे पास भी है,
वो आप वाला ही चाहिए।
ठीक है सर मेरे पास है,
वो अपने
बस एचओडी के सिग्नेचर करवा लें,
वो
मैं
करवा
आपको
करवा
ठीक है सर,
थैंक यू।
वेलकम।
Bismillahirrahmanirrahim. In the name of Allah, the most merciful and the most beneficent. So now we are going to start our lecture. Muhammad Rahman. Can you hear me? Aisha Zubair. Muhammad
जी
Rahman
सर।
can. Okay, please, if there will be any distortion in the voice or the stillness of slides, please let me know. Okay, thank you
ओके
so much.
ओके।
So last time we discussed about last time we discussed about what is data, how to organize the data, what is the structuring of data, how we generate arrays, what is list, stacks, advantages, disadvantages, classification of structural classification of data structure, primitive data structure, non-primitive data structure, and what is the differences between these two, at which position, at which class we have to use which one. So we discussed about that in our next lecture. So now we are going to move on. Queues. What is queue? In your daily life, you guys know about queue in a bank or in any place where you have to stand for a specific task. That is known as queue. And in data structure, what is queue? Queue are the first in and first out type of data structure. That is also known as FIFO. FIFO. So if you stand first, then you will be in the queue at the first position. And suppose there are 10 persons or 10 queries in one line. So the last one will be on last, and the person who will be who entered first in the queue will be entertained first. Like if there is a bank and bank is closed and you went there at the first position, you will be there, and then there will be 10 more persons behind you. So you reach there first, then you will be served as first. That is the concept of queue in data structure. In a queue, new elements are added to the queue from one end called known as rear, REAR. Rear end and the element are always removed from other known as front end. From the front end, you will be entertained by the specific person. Similarly, if you have a data or maybe you have the entry or maybe you there are 10 students in the class and everyone has different marks in their intermediate. So if we make the data structure or organizing the data of all the marks of the students, then we have to generate an array. Last time we studied in our lecture, and at that time first position we have marks, suppose a person A and marks is 599, then person B, C. So we generate the queue like this one, and when we enter the data from the end is known as rear, and the last where we completed our data or array is known as front end. The people standing in the railway reservation or banks row are an example of queue. So each new person comes and stands at the end of the row, and the person getting their reservation confirmed get out of the row from the front end. The below show figure how the operation take place on the stake. So sorry, on the queue. So here you can see there is a typographical mistake. I'm going to fix it, and I don't know why this tab is here. Here should be queue, not a stake. QUEUE. Okay. So here we have an example. There is five boxes that has some specific number like 10, 20, 30, 40, 50, or you can say the ages of the different members of a family, or you can say the marks of the students in a class. So the first one is the front end of the queue, and the last one is the rear end of the queue. So from the the first one will be entertained first and the last one will be entertained in the last. That is the concept of FIFO. The queue can be implemented into two different ways. You can use arrays, that is known as the static implementation of the queue, and you can use pointers, and that is known as the dynamic implementation of the queue. So you have to arrange your data accordingly where you need. You have to generate the queues, you have to generate the stakes, you have to generate the linked lists, and similarly you have to generate the arrays. So what are the applications of queues when we have different type of data? If you guys know about simulation, how we simulate the data, simulation is try to generate real-time environment in the computer. That is known as simulation, and then we just generate specific type of environment and then give a specific protein or any type of data. I hope you guys remember what is the value of pi. There is a sine pi that is, I remember, as 22 by 7, and the answer is 3.10444, something like that. That is the first simulation we performed in our life when we were in our childhood. The calculator showed 3.7111111. In actual, that's the simulation that couldn't stop. Or then you have, or otherwise you have to make a specific cut in your for loop, like we usually have, that this 111 will be on 10 times, 20 times. So that is also a simulation. Various features of operating system. We also used queue. There are multiple programming platform systems, different types of scheduling algorithms. Last time we discussed in detail about algorithm. I just want to remind you that algorithms are the series of steps to perform a specific type of function. And then we have a printer server routine. Various application softwares is also based on queue data structure. After that, we have trees. Actually, all the concepts in computer sciences or other sciences, usually you guys will observe that derived from nature. That if we have the concept of trees in data structure, that the same concept we derived from nature. That how a natural tree grows up, like where the roots are, where the shoots are, and leaves and trees and nodes and branches. Similarly, in trees, we have similar concepts. A tree can be defined as a finite number of data items. Suppose you have 20 members or 30 students in the class, and you have finite number of data, not infinite number of data. Suppose if we are just going to add a data that we don't know how many candidates will be there, then we cannot move to the trees. However, if we just know that there will be only 30 candidates or there will be 20 students in the class, then we will generate the trees. Tree is a non-linear type of data structure in which data items are arranged or stored in a sorted sequence. Tree represents the hierarchical relationship between various elements that are present in the tree as nodes. So that's the relationship between the elements, hierarchical representation of the data, that how the one data is represented to other one, and how what is the relationship between these two datas. So here we have a table that has different fields and descriptions like root, parent node, child node, siblings, path, height of tree, depth of node, degree of node, and edge. So what is root? Root is a special node in a tree. The entire tree is referencing through it. It does not have a parent. As you guys know that in a natural tree, there is a root, and root just gives everything to the tree. So there is no parent of a root in the case of data structure. Similarly, after that we have parent node. And what is parent node? Parent node is an immediate predecessor of a node. Then we have a child node. All immediate successors of a node are its child. After that, we have siblings, and nodes with the same parents are known as siblings, like you guys are siblings to each other with your brothers and sisters. Similarly, we have siblings. The data extracted from two different same node is known as sibling. Like bifurcation, you can also say as a bifurcation. Then when you have a one node and you have two child, similarly, like you have one parents and there are three child, that are known as siblings. Similarly, in the tree, siblings is known as that are from the same node node and with the same parent. Then we have a path. Path is a number of successive edges from source node to destination node. Similarly, this concept is also from the nature that how a path covers. Suppose you want to go to your home from a specific path. So similarly, path is a number of successive edges from the source from where you want to move the nodes to the destination node where you want to reach. Then we have height of node. Height of a node represents the number of edges on the longest path between that node and a rear. Then we have a height of a tree. Height of a tree also depends on the number of elements or data you have and the root node. Depth of the node is also depends and represents the number of edges of the tree, root node to the node. Degree of node represents the number of children of a node. Edge is a connection between one node to another. It is a linear between two nodes or a node and a leaf. So I am going to stop the lecture here and we will continue it later. There is some problem and I cannot deliver it in a good way. So I don't want the lecture will be in a bad manner. So thank you so much everyone for joining. If anyone has any question, please let me know. Please raise your hand if you have any question. We will continue later after some hours. I will let you know. Anyone has any question, please raise your hand. Thank you so much everyone for joining.